Hello, I'm Jim Dowd, a technical consultant and owner of Innovia LLC.
Hi, I'm Dr. Steve Zalek, and I'm the president of Sea Systems Research, LLC, and I'm also the associate director of the University of Michigan Marine Hydrodynamics Laboratory.
Today we're going to be talking about wakesurfing, which is an activity done behind inboard-powered towboats. Wakesurfing is an exciting sport for the general population, not just because it brings the experience of surfing on the ocean right to your local lake, but because it's so easy to learn that riders of all ages can have fun behind the boat. The popularity of wakesurfing has been increasing tremendously over recent years, and in response to this, the different boat makers are coming up with innovative solutions in wakesurf systems.
We picked Mastercraft and Malibu as the two benchmark products because they represent by far the largest market share in this product. And we chose a range of boats within each of those companies from 20 to 24 feet so that we could see the impact of the different boats on the performance.
We decided that the best thing to do to help cut through all the subjectivity and marketing noise would be to develop an independent and unbiased study of the different wakes made by boats, and we do this using objective, numbers-based measures. We took each of the 6 boats out on the water to compare them. We loaded them with factory ballast per the manufacturer's settings and adjusted the different wake systems for the port and starboard side of the boat. Using a combination of cameras, reflective spheres, and sensors, we were able to collect data points on the wake size and length. And using this data, we were able to create a 3D digital map of each of the wakes. As you can see from this young amateur surfer, we were able to determine the area of push by using a rope that was instrumented with a force gauge. Where he was propelled by the wake without any strain in the rope, there was enough push. And when he had to hold on to the rope in order to stay up with the boat, then there wasn't enough push. The second aspect we looked at was how long it took to switch from one rider to another. Most wake surfers, when they're learning, can only surf on one side of the boat wake, with their toes pointing to the wake. It's very convenient for everyone on the boat if it's easy to switch from a rider who surfs on the starboard side to one who surfs on the port side and vice versa. And so we measured in time how long it took to switch each boat from surfing on one side of the boat to the other. The third thing we examined was the user interface, in other words, how easy it was to set up the boat for wake surfing. Each boat comes equipped with its own unique control system that lets you, the consumer, prepare the boat for surfing. The easier those controls are to comprehend, the fewer clicks to operate the system, the easier it is to see the different aspects of it, the better the system is for control. We examined each of these attributes and where possible measured them so that we could see which was the best control system. The fourth aspect to describe is the handling of each boat. When you're driving a boat at speed and switch from creating a surf on one side to the other, the boat will begin to change direction. It takes some amount of rotation of the wheel to correct that turn and to continue going in a straight line. By measuring the starting position and the end position of the wheel in order to keep the boat going straight, we determine the total degrees of rotation of the wheel. In addition to these 4 characteristics, we also analyzed several other aspects of performance that impact consumer satisfaction. For example, fuel efficiency when surfing, the degree of drag created by the surf system resulting in increased RPM, the air quality in terms of low levels of carbon monoxide, the noise level at surf speed measured both inside and outside the boat, that is behind the boat where the surfer would be, and finally how much the boat pitches and rolls during the deployment of the surf system.
Just like, and our brain can make an estimation as to how far away something is in the distance. These cameras and special software can do the same thing. So we put some markers out on the waves. These are data acquisition spheres, and they ride the surface of the wave. These cameras are going to pick up those points. We're going to triangulate the distance to those points. Then we're going to pass a mesh through those points and map the surface of that wave. This way we can capture its height and its angle and its shape relative to the boat.
Using the test method just described by Dr. Zalick, we were able to dimension the wake produced by each of the boats in terms of length, width and height. We also verified these dimensions using push measurements from the instrumented rope that was described earlier, and by conducting a two-dimensional analysis at various positions within each of the surf zones. Now, looking at the graph to the right, you can see that in all three boat classes, the Gen 2 equipped boats produced a more substantial wake than those with surfgate. Looking at the boat sizes individually, the total wave energy produced by the Mastercraft X46 was 24% greater than that measured on the Malibu 24 MXZ, and on the X30 it was 2% greater than the 23 LSV, and finally on the NXT it was 3% greater than the Axis 20. In the fuel consumption series of tests, we wanted to know which of the two systems, the Surfgate system from Malibu or the Gen 2 system from Mastercraft, was the more frugal. We tested all 6 boats and measured the fuel flow at surf speed with the surf system deployed using a Diacom PC-based diagnostic system. The results from these tests are shown in the black chart to the right. Each of the 3 boat sizes has the Malibu Surfgate on the left. And as you can see from these results, in all 3 cases the Mastercraft Gen 2 system performed better. The NXT was 7% better than the Axis, and on the larger boats the difference was a more dramatic 60 to 70% advantage to Gen 2. At the same time as we measured fuel consumption, we also observed engine speed, again using the Diacom diagnostic system. As one might expect given the previous fuel economy results, the Malibu boats were having to work harder to overcome the drag created by the Surfgate and the wedge, and as a result the engine speeds on the Gen 2 Mastercraft systems were lower by between 6 and 15%. In fact, in all 3 cases the Mastercraft engine speed was below 3000 RPM while surfing. Next we measured carbon monoxide levels in and behind the boats while in surfing mode. In all 3 cases you can see that the CO levels are considerably lower in the Gen 2 equipped Mastercraft boats. The NXT measured 6 parts per million average between the 3 sampling locations compared to 140 on the Axis 20. Same test on the Mastercraft X30 was 70 parts per million, 70, compared to 288 on the 23 LSV, and 33 parts per million on the X46 compared to 221 on the MXC. Noise levels were measured in 3 different zones of the boat during surfing, those being the driver's seat location, aft seating location, and 3 feet after the transom. As you can see from the results, we have a mixed situation with the Mastercraft boats being quieter on the inside during surfing and the Malibu boats being quieter on the outside. Here we're looking at how much the surf system causes a boat to veer off course and how much steering wheel force is needed to correct this tendency. As you can see from the results, once again this is Advantage Gen 2 with less heading change in all 3 of the boat size categories. In terms of the force required to correct this heading change, on 5 of the boats the force was insignificantly low, with less than 3 pounds to keep the boat going straight ahead. But the 23 LSV needed a fairly high 14 pounds to keep the boat going straight ahead. Here we measured roll, that is how much the boat rotates about its longitudinal axis when the system is deployed. Whether surfing left or surfing right, the Surfgate equipped Malibus rolled an unnoticeable 3.5 degrees or less. The Mastercrafts, on the other hand, rolled more, with rotation of up to 6 degrees. Still not an amount that is easily noticeable when riding. The purpose of this series of tests was to measure pitch, that is the amount that the bow rises in relation to the stern when surfing. As expected, the shorter the boat, the more it pitched bow up. In looking at the results, you can see that we measured very little difference between the Surfgate system and the Gen 2 system in each of the boat classes, all of them pitching between 10 and 12 degrees with the exception of the Mastercraft X46, which had less than 8 degrees of bow rise. The last dynamic series of tests we did was to measure how long it took to switch each boat from surfing on one side to the other. We used the data acquisition traces to see the total time taken to complete the maneuver, and then verified the results by analyzing the video footage from each switch. As can be seen from the results, there was not a big difference, with all of the boats being able to reposition the wake for opposite side surfing in between 4.4 and 6.3 seconds. So to wrap up, this chart summarizes how the Mastercraft Gen 2 surf system and the Malibu Surfgate system stack up relative to one another in each of the boat size categories. The comprehensiveness of the study and the range of performance measurements accumulated over many days of testing should be sufficient to answer all of the questions consumers may have relative to these systems. For a full report, download from the attached link.